All right, allow me to introduce a few more examples, finding some particular solutions to differential equations. Find f if f prime of x is equal to e to the x plus 20 over 1 plus x squared, and f of 0 is equal to -2. So once again, we have an initial condition, and our initial condition here is the coordinate 0, -2. So we should be able to find our c value. Now, notice that our derivative here, our differential equation, has this fraction, this rational equation. And wait, have we talked about how to find the antiderivative of a rational function? Yeah, just like one of them. Do you recognize this as being the antiderivative of something? Maybe you recognize that if it didn't have the 20 on it and it just had 1 over 1 plus x squared. Would you recognize it? Isn't that thing arctangent? It sure is. So let's step by step find the antiderivative, the general one first. So f of x should be equal to antiderivative of x of e to the x is super sweet. It's just e to the x. All right, ignore the 20 for right now. The antiderivative of 1 over 1 plus x squared should be arctangent, and that 20 is just a constant multiple. It'll come along for the ride. Just cram it right up front. 20 arctangent x. And don't forget that plus c. I almost did. And once again, I'll just reiterate the fact that if you forget your plus c, you're solving a differential equation on the AP exam, you forget your plus c. On a multiple choice question, it'd be almost impossible because it's not like they're going to leave off the plus c. But on a free response question, yeah, it's a pretty common thing. And if I forget it, I lose that point. They always give a point for. It's usually a combination of that plus using your initial condition, and then anything after that you don't qualify for because you can't do anything else with it without having your plus c. So speaking of your plus c, let's get rid of it by plugging in 0 for our x's and setting that thing f of x equal to -2. So e to the 0 plus 20 arctangent of 0 plus c. Oh my gosh, this is a non-calculator question. Can we handle it? E to the 0, e to the, I don't, if it's something raised to the 0 power, should be 1. -2 is equal to 1 plus, and then what is the arctangent of 0? Well, just think of the tangent graph here, which looks like this. It passes through the point 0, 0. So if you take the inverse of 0, 0, you get 0, 0. So the arctangent of 0 is just 0. So 20 times 0, it's 0. Plus c, subtract over your 1, and you can see that your c is equal to a -3, I think. And then finally, let's find f. F of x is equal to e to the x plus 20 arctangent of x, and then finally minus the 3. That's right there. You can always check your answer by taking the derivative because you know what the answer to this derivative is supposed to be because it was given to you to begin with. Let's do another one. Oh, this one is a second derivative. Find f if f double prime of x is equal to 12x squared plus 6x minus 4. And notice it gives us two initial conditions, and it has to because we're going to get a plus c when we work backwards from f double prime to find f prime, and then we'd get another one working backwards to find f. Okay, so we're going to take this in a whole bunch of different steps. So I'm going to first find f prime by taking the antiderivative of f double prime. We'll just get rid of one of these prime marks. So it'll be, where are you going? Where are you going, slide? F prime of x is equal to, term by term, 12 x to the third divided by 3. Of course, maybe you could do some of that in your head. Do a little division there and you get a 4. Plus 6x, add 1. 2 divided by 2, do that division, you get a 3 there. Minus 4x, and then don't forget your plus c. It's at this point that you should probably go ahead and, oh, but I can't. I've got two f's. I was thinking that what I had was f prime of something was equal to something else, and then I could stick that in there into the first derivative, but yeah, I don't have that. So yeah, I'm just going to have to keep going then. All right, let's do it. So let's get rid of this prime mark by finding another antiderivative. F of x is equal to, add 1 to the exponent again, 4x to the fourth divided by 4, 4's cancel, plus 3x cubed over 3, 3's cancel, very convenient, minus 4x squared over 2, this time they don't cancel, but it just reduces, plus cx. And then you need another constant of integration. Since I ran out of c's, I'll just use a d. Constant integration is now a d. All right, there we go. So now we have to plug in both initial conditions so that we can find both the c and the d. You know which one I'm going to plug in first? I'm going to plug in 0. And I don't even have to write much down, because if I plug in a 0 here, a 0 here, a 0 here, 0 here, all these cancel, and we're left with d is equal to the 4. Did that make sense? Plug in zeros for all of these are going to cancel. You're only left with d is equal to 4. So I'm going to get rid of this d right here. I'm going to put a 4 in its place right there from that first initial condition. Now we'll plug in a 1 for all of our x's. Boop, 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 boop. And set the whole thing equal to 1. This one I might have to write some stuff down. So 1 to the fourth plus 1 to the third minus 2 times 1 plus c times 1 plus 4. All right, look how convenient this is. This 1 plus this 1 makes 2, which cancels out with that 2. And then take this, a 4, and let's say we subtract it to the other side over here. I'm going to get c is equal to -3. Okay, one last thing. Let's rewrite the whole entire function then. With all the c's and the d's in place, I have f of x is equal to x to the fourth plus x cubed minus 2x squared minus 3x, that's the 3 that we just found, the -3 we just found, and then plus 4, which was the d that was there. And voila, we have our f of x function given the second derivative and then 2 initial conditions. All right, I'm going to leave you with one problem for you to try on your own here with example 9. A little bit different. The graph of f prime appears below. Sketch the graph of f of x given, and we have an initial condition. F of -3 is equal to 0. So we've seen this function actually before. It's from a released FRQ. We know that this is the graph of the derivative. It's only showing us the slopes at each and every point of the original function f of x. But now we know where this graph is supposed to start, or yeah, it is where it starts because it's going from -3. So this graph, the original f of x graph, has to start here on the x-axis at -3. And then it has a positive slope here until it gets to -2, so it's got to increase, right? This is supposed to be, let's see, our derivative switches from positive to negative, so that's got to be a maximum point here. Then it's going to start decreasing from that point. All right, you get the picture. You draw a picture of this. You sketch a graph of this, given this initial condition here.